Hello and welcome to a demonstration of how to use the ImageflowRT interface. In this demonstration, I'll show you how to start inspections, stop inspections, view the details of an inspection in real time, and modify the configuration of an inspection job. When you first open ImageFlow, you'll see the Select Working Directory screen. This is where you choose the working directory to open, which contains all the configuration information to do with all inspection jobs. So you can choose from a previously created working directory, or you can choose to create a new directory. To create a new working directory, you hit the button at the bottom left here, and you must select a folder that has already been created in Windows. If you cannot find a folder that is suitable, you can simply make a new folder by clicking this button here and naming it a suitable name for your working directory. For the purposes of this demonstration, I'll open up a previously existing working directory which holds a sheet inspection. So you'll see when you open up ImageFlow, in the interface there are three main sets of buttons. The set of buttons here, and set of buttons here, and the set of buttons here. This set of buttons are to do with the live display viewed during inspection. So you can edit the characteristics of the live display you are viewing. The buttons down here have to do with starting, stopping, and modifying the operation of an inspection, as well as modifying the tools, lights, digital I/O, and alarms that the inspection uses. The set of buttons on the bottom right manage the inspection job in general, giving you access to the inspection browser, different recipes that have been set up, image source control and profile configuration, and the ability to turn on and off the inspection at the application and change to another application within the ImageFlow suite. So the first set of buttons I'll show you how to use are the set of buttons at the bottom left here, which allow the user to start, view, and stop an inspection. If I hit the view button here, we'll see a live display of the web, but no detection will be carried out. If I hit the detect button here, we'll start the inspection and go to the detect state. So we'll start detecting defects based on the tools we have set up in Tool Manager. The detection can also be stopped. The inspection can also be stopped using the stop button here. The next set of buttons here contain access to the tool panel, the light panel, the digital I/O panel, and the clear alarms panel. The tool panel allows the user to edit the configuration of any tools that have been set up in Tool Manager. So for this inspection, we had web edge detection and adaptive surface inspection set up. So here we can edit certain parameters to do with the web edge detector, including turning it on and off and editing the trim. The parameters that you can change for each tool vary from tool to tool. So you can also edit the intensity and configuration of the lights if one was set up or connected. You can also set up how the different outputs to the digital I/O, and if any alarms have been triggered, you can clear them using the clear alarms button. For the purposes of this demonstration, we just have the tool panel set up and none of the others. So the next set of buttons here allow the user to edit the display of the web that is viewed. So as you can see here, we have show last failed frame and toggle overlay graphics enabled. So show last failed frame means that the display shown is always the last frame which contain a defect. If I change it to live display, we'll see a constant representation of the web with defects popping up in real time. So last failed frame is useful just to get a quick snapshot of the last defect that was found. Toggle overlay graphics, toggle whether the defect overlays are shown. So if I turn this off now, there'll be no overlay shown where there was one. I can turn it back on, and defect overlays are shown again. The camera button here allows the user to save a screenshot of the currently displayed web. This is useful if there's a particularly interesting defect found, that you could then save the frame and for future reference and view it at a later time. The zoom to fit here means that if I was to zoom in at a particular point, I could then hit the zoom to fit button and I'll zoom back out. The display on the right hand side allows the user to view the details of the currently running inspection. So the defect list gives an indication of the position of each defect, the time it was found, the tool that it was found using, and the class name of the defect that was found. If you click on a specific defect, it gives you all the measurement details that are to do with that defect. So you have the center of mass X, center of mass Y, width, length, area, and the intensity. These parameters and measurements can be changed in the tool manager interface. The defect map gives an overview of where the defects were found on the web and gives the user a quick graphical representation of all the defects in the web. For the purposes of the demonstration, I've set up this inspection to have particularly strict defect finding parameters. So there are, as you see, you get a good representation of all the different defects, and there are a lot of them on this web. You can also toggle which tools you want the defects to be shown from. So if I just wanted defects to do the web edge detector to be shown on the defect map, I could deselect all the other tools. Or if I didn't want the web to show any defects to the web edge detector, I could deselect that and just have defects found from other tools shown on the defect map. As in the defect list, clicking on any defect in the defect map will bring up a representation of the defect as it was found in a frame, and will also show all the details to do the measurements of that defect. So if I click on one here, and finally the measurement table allows the user to view the details of all defects found and filter that by the tool. So adaptive surface inspection has all the details to do with the measurements used in adaptive surface inspection for each defect that was found, and web edge detector has all the details to do with the inspection carried out by the web edge detector. You'll also notice the counter widgets at the bottom right of the screen here. Each of these correspond to information relating to the current inspection: the amount of fails detected in the current inspection, the distance since the last fail was found, the time of the last fail, the speed of the inspection being carried out at the moment, and the total amount of substrate that has been inspected during the current inspection. Once you hit the stop button and stop an inspection, it gives you access to all the last group of buttons in the Imageflow runtime interface. The inspection browser allows you to view all inspections that have been carried out in this working directory and assign job IDs to them. The recipes panel allows you to choose a recipe that this inspection will be carried out using. This button allows you to change what the image source that you're using to carry out the inspection, as well as access the profile configuration screen by pressing that button there. And the power button allows you to either close the application or switch to another application within the Imageflow suite. So you can switch to Tool Manager or Veriflow. Thanks for listening to this demonstration.